Okay, I wanted to continue today working on some examples of evaluating limits, and particularly we want to look at all problems in this video of functions that are kind of split up with two curves the way we have it here. So let's just look at our graph in this function. So we've defined it in a way, you can tell this is the curve of x cubed plus 2 here, and we defined it so that when x is less than 1, okay, we've defined this function to be this, our x cubed plus 2 curve right here. And then when x is greater than or equal to 1, it's just going to be this line 6 minus 3x. So it's going to be defined down in this region. So actually this upper part of the curve is not really there for this function, it's just there to show the full curve. And to get started with our first limit problem, we're asked to find the limit as x approaches 2 for our function f of x. So first we want to actually look at how this is broken up. So when x is approaching 2, we're going to want this 6 minus 3x because it's greater than 1. So we're actually looking at this part of the curve here, and you can kind of see here at 2, this looks like 0. If we plug a 2 in there, we get 6 minus 2 times 3. So this limit's easy, it's just going to be 0. At this point, x equals 2, there's really nothing complicated going on. So sometimes finding the limit is just really straightforward, and it's just like plugging in the value. Okay, next we're asked to find, we want to find the limit as x approaches 1 of f of x. So our 1 value is right here, and so that's going to be right at this intersection point. So what we want to do to evaluate this, we want to look at the right-handed limit and the left-handed limit. So we're going to want to look, so we're just looking at points really close on both sides of x equal to 1. And so the way I want to look at this is we can evaluate this separately. We can look at the value of limit as x goes to 1 plus. Okay, that's just the right-hand side of 1. That's just these values that are greater than 1. So we can look at what that value is. And then we also have to look at the left-hand side, 1 minus. Okay, so that's just these values over here on the left side, slightly less than 1, like maybe 0.999. Now for this first piece, for 1 plus, we're going to be looking at this here, 6 minus 3x, because it's going to be values that are slightly greater than 1. Okay, so we'll use this function. If we plug in 1 here, we get 6 minus 3, and this is going to evaluate to 3. And then evaluating this piece, when x is approaching 1 minus, when it's approaching from the left side, well, for less than 1, if we're like 0.999, we're going to be using this first function, x cubed plus 2. If I just plug a 1 in here, we get 1 plus 2 or 3, and you kind of see, just looking at the graph, I know it's kind of squeezed in tighter, but we're saying this point here is at 3. So on the left-hand side, this is also going to be 3. And because we're approaching the same value on both sides, and kind of just looking at the graph too, you can see that this limit is going to be approaching 3. Okay, so next we're using the same graph, and we've got the same line and the same curve here, but I did make a subtle change here. We changed the definition here where it's changing now at 2. So if we kind of just get a sense of this, if we go down here, we're saying when x is greater than or equal to 2, it's going to be this line 6 minus 3x. So these are going to be the values when we're looking at x greater than or equal to 2. Now when x is less than 2, let's kind of come up here. Here's our 2 point. All these values less than 2 are going to be defined by this x cubed minus 2 curve. So now for the problem we have here, we're asked to find the limit as x approaches 0 of f of x. Here's our 0 point right here. So at 0, 0 is less than 2. We're going to be using this first curve, x cubed plus 2, and coming right up here. And that value, you can't see it too well, but if you plug a 0 in there, you'll find this limit is actually going to be just 2. Okay, now I think that's pretty clear and easy, but if we look at our next example, we want to find the limit as x approaches 2 of f of x. And what we're going to do is the same thing we did last time, is we're going to need to look at this from the left side and the right side. So we're going to want to look at the limit of x at 2 plus. And the reason I'm doing this, by the way, is because at 2, this is kind of where things get complicated, right? Because the function's changing. So we're going to look at this from the right side, and we're going to look at this at x approaching 2 minus from the left side. Okay, so for 2 plus, looking at it from the right side, we're down here on this 6 minus 3x line, right, when x is greater than or equal to 2, because we're on the right side. So here at 2 plus, we're going to be looking at a value like, let's say 2.001 or 2.001, whatever, or 2.01 or something just on the right side here. And you can see that this is going to be on this line, 6 minus 3x, because we're greater than 2 here. So we're going to evaluate this at 6 minus 3x. And if I just plug a 2 in here, you'll see that at that point, this is going to 0. And then now if we evaluate this from the left side at 2 minus, we're going to be looking at a point like in here somewhere, just on the left side of 2. And you can kind of see this is approaching some point here, because because we're less than 2, we're going to be using this curve. So we're going to be using x cubed plus 2. And if I just evaluate this at 2, 2 cubed is 8 plus 2. This point here is 10, so our limit here is going to be 10. So now getting back to this problem, we want to find the limit as x is approaching 2. Well, from the right side, it's approaching 0. From the left side, it's approaching 10. So these two values, of course, those are not equal. So because these two aren't equal, we're going to say that this limit does not exist. So just notice sometimes you're going to run into this where the limit's not the same on the left-hand side and the right-hand side, and we just say the limit doesn't exist, and that's the way we handle this. So we'll stop it there. More limit videos coming. Thanks for watching. Have a great day.